ನಮಸ್ಕಾರ ಸ್ನೇಹಿತರೆ. VBSM ಶೈಕ್ಷಣಿಕ ಕಲೆ ಮತ್ತು ವಿಜ್ಞಾನ ಶಾಲೆ, ಕಲ್ಯಾಣ ನಗರ, ಬೆಂಗಳೂರು. ನಮ್ಮ VBSM ಶೈಕ್ಷಣಿಕ ಶಾಲೆ ಗ್ರಾಮೀಣ ಮಕ್ಕಳಿಗಾಗಿ ವಿಶೇಷ ಕಾರ್ಯಕ್ರಮಗಳನ್ನು ಹಮ್ಮಿಕೊಂಡಿದ್ದೀವಿ. ಅದರಲ್ಲಿ ಇಂಗ್ಲಿಷ್ ಮೀಡಿಯಮು ಮತ್ತು ಕನ್ನಡ ಮೀಡಿಯಮು ಎರಡೂ ಸಹ ಜೊತೆಯಲ್ಲಿ ಮಾಡ್ತಾ ಇರೋದ್ರಿಂದ ಎರಡರಲ್ಲೂ ಮಕ್ಕಳಿಗೆ ಒಂದು ಪರಿಣಿತಿ ಸಿಗಲಿ ಅನ್ನೋ ಉದ್ದೇಶದಿಂದ ಇಂಗ್ಲಿಷ್ ಮೀಡಿಯಮು, ಕನ್ನಡ ಮೀಡಿಯಮು ಎರಡೂ ತರಗತಿಗಳಿಗೆ 2 ವರ್ಷನ್ಸ್ಗೆ ಮೀಡಿಯಮ್ಗಳಿಗೆ ಹೇಳ್ತಾ ಇದ್ದೀವಿ. ಇದರ ಉಪಯೋಗವನ್ನು ಗ್ರಾಮೀಣ ಮಕ್ಕಳು, ಗೋಪನಹಳ್ಳಿ, ಚಳ್ಳಕೆರೆ ತಾಲೂಕು, ಚಿತ್ರದುರ್ಗ ಜಿಲ್ಲೆ, ಕರ್ನಾಟಕದ ಎಲ್ಲ ಗ್ರಾಮೀಣ ಮಕ್ಕಳಿಗೂ ಇದರ ಉಪಯೋಗವನ್ನು ಪಡೆಯಲಿಕ್ಕೆ ಸಹಾಯ ಆಗುತ್ತೆ ಅನ್ನುವ ಒಂದು ಉದ್ದೇಶ ಕಳಕಳಿ. ಬನ್ನಿ, ಈ ದಿನ ನಾವು ವಿಜ್ಞಾನ ತರಗತಿಗಳು 10ನೇ ತರಗತಿ, SSLC 10th ಸ್ಟ್ಯಾಂಡರ್ಡ್ 15 class, lesson number 15. Dear students of Gopanhalli, every day log in at 5 p.m. to VBSM Academy. Please follow up your studies with the following disciplines: fresh up early in the morning prayer, attend school, respect your teachers and parents, say good morning to them, then log out at 6 p.m. say good night to VBSM Academy. Bunny, let us study the science classes. Now, last class we have studied about there are 5 types of chemical reactions. Do you know today's class is chemical combination classes? Before that, I would like to give introduction to the combination reactions. There are 5 types of chemical reactions. Let us discuss about how many types of chemical reactions, which is called as CDDP. That is our own way of methods of remembering CDDP. CDDP means, my dear friends, CDDP. Try to remember. CDDP, easy to remember these things. Let us develop our own way, our own method of remembering certain things. Okay, what is that CDDP? CDDP is nothing but first C, chemical combination. Second D, decomposition reaction. Third D, displacement reaction. Last D, double displacement reaction. P, precipitation reaction. All these abbreviation stands for chemical reactions only. Okay, combination reaction. A plus B is equal to C. A combines with B gives C. It is a general formula. A plus B, A and B are reactants, C is the products. Similarly, decomposition reaction. Decomposition means splitting. Any reactant can split into the respective components. A gives B plus C. A is the reactant, B plus C are the products. Okay, displacement reaction. AB combines with C gives C displaces B, gives AC plus B. That is, B is displaced from the reactant side when it is coming to the products. That is displacement reaction. It is also called as cocoa reaction. Cocoa reaction. Cocoa players are very easy to know what is cocoa. One player is coming and say co and is taking that place, and that previous fellow will go and run, is displaced from the original place. That's how this is the cocoa place. That's called displacement reaction. Next, double displacement. It is AB plus CD gives BC plus AD. So that means it is an exchange of the radicals. Double displacement is nothing but the exchange of radicals between the reactants and the products. Well friends, next, precipitation reactions. Precipitations or reactions are the same thing, exchanging the radicals and forming the precipitation reactions. A colorless solution is converted into beautiful different types of precipitation reactions. These things we will be discussing shortly in the forthcoming chemistry classes, my dear friends. Okay, today, combination reaction. A chemical combination occurs when matter changes forms, properties, and characteristics when it reacts or combines with another matter in a chemical reaction. So the combination implies the loss of chemical combination. What are the loss of chemical combination? Govern the relationship between the matter, energy, and transformation in chemical reactions. For example, magnesium combines with oxygen gives magnesium oxide. Last class we have already discussed by rubbing, by snapping the magnesium ribbon with the help of a sandpaper, and it will become shining. Then it will ignite with the help of a Bunsen burner or a spirit lamp, gives it burning with a dazzling light, gives magnesium oxide. Now we see magnesium ribbon burning with the help. This is a pair of tongs. After burning, it gives a dazzling light and forms finally it white powder, the white ash of magnesium oxide, which is collected in the glass, where a glass, watch glass or china dish. Similarly, when carbon burns in oxygen, gives carbon dioxide. Carbon, any matter, carbon, charcoal or whatever it may be, that it burns with the help of oxygen. Oxygen is a supporter of combustion. The combustion takes place here. The carbon burns in oxygen, gives carbon dioxide, that is burning carbon particle, and you will get, this is the oxygen and the carbon dioxide. This is solid carbon. It burns with oxygen, burn by taking oxygen, by consuming oxygen, gives carbon dioxide. So therefore, my dear friends, this is the very good example for combination reaction. Two reactants combined together to form a single product is called chemical combination. Magnesium combines with oxygen, gives magnesium oxide, and carbon combines with oxygen, gives carbon dioxide. Well, types of chemical reactions in which the law of constant composition states that the properties are, types of chemical reaction. Combination reactions are three laws of combination. It leads to the study of further three types of chemical combination. Three types of chemical combination, which are, one is law of constant composition. What is that law of constant composition? You see, when carbon dioxide may be prepared in the laboratory, you see, carbon dioxide can be prepared by burning calcium carbonate, or by burning carbon in oxygen, or by calcium carbonate reacts with hydrochloric acid, or by sodium bicarbonate. These are the ways of preparation of carbon dioxide. Whatever may be the preparation of carbon dioxide or the formation of carbon dioxide, here you can see very important is, in all the above cases, in all the above examples, carbon dioxide is made up of the same elements, that is carbon and oxygen. It is the component. Carbon dioxide is nothing but is made up of carbon and oxygen, you know that. So carbon and oxygen is concerned, it is combined together in the same fixed proportion, that is 12:32. Simple. And mathematics here is take the common factors 12 and 32, you will get that is 4 3 is the 4 8 is the 32 common factor. Then it becomes 12:32, or it may be 3:8. This is law of constant composition. 3:8 is the law of constant composition between the carbon dioxide formation, irrespective of different types of chemical reactions during the formation of carbon dioxide. That is formation of carbon dioxide. Okay, well, we will pass on to the second, the law of multiple proportions. What is that multiple proportions? A single element combines with combines with another element with the same or with the multiples of the atoms. For example, nitrogen. Nitrogen is having a variable valency. Nitrogen is having variable valency means in some cases nitrogen valency is 1, in some cases valency is 2, 3, 4, 5, and hence the variable valence state of nitrogen is one nitric oxide, nitrogen peroxide, it is nitrous oxide, nitrogen nitrogen dioxide, and this nitrogen tetroxide and nitrogen pentoxide. In all the cases, valence states are different, and hence nitrogen and oxygen ratio 1:1, 1:2, 2:1, 2:2, 2:85. Like this, it will have its own multiple proportions with nitrogen and oxygen. Similarly, in case of carbon, carbon combines with oxygen forming carbon monoxide, and carbon combines with oxygen and gives also carbon dioxide. If carbon combines with one atom of oxygen, it leads to the formation of carbon monoxide, that is CO, and if it combines with two atoms of oxygen, it gives carbon dioxide, and hence 12 grams of carbon is combined with 16 grams of oxygen in case of carbon monoxide. The same 12 grams of carbon is combined with 32 grams of oxygen, gives carbon dioxide. That's why it is called law of multiple proportions. Well, the third one is the law of equivalent proportions. What is that law of equivalent proportions? Equivalent, almost equivalent is different. For example, when here you see, consider formation of sulfur dioxide, and that is the relation between sulfur and oxygen. Sulfur bonds in oxygen gives sulfur dioxide. For example, if two elements A and B each form a compound with the third element, gives sulfur dioxide. Here sulfur is one element, oxygen is another element, and sulfur dioxide is another compound. Therefore, percentage of sulfur is equal to 50, percentage of oxygen is 100 minus 50 is equal to 50. That means percentage of sulfur is 50 and percentage of oxygen is 50 here. Therefore, 50 grams of sulfur combines with 50 grams of oxygen. The ratio of mass sulfur to that of oxygen is 50:50. Therefore, it is 1:1 ratio. The second ratio is a simple whole number is multiple of the first ratio. Hence, the data illustrate the law of reciprocal proportions. For example, 12 grams of carbon react with 4 grams of hydrogen in methane. In case of methane, it is different in every chemical reactions. But whatever may be the chemical reactions, the law of equivalent proportions remains the same in all the chemical reactions. For example, during the formation of methane, 12 grams of carbon reacts with 4 grams of hydrogen. You know CH4, carbon, 12 grams, carbon, and 12 grams is the carbon, this thing. What is that 12 grams? For example, carbon is 12 grams. What is the hydrogen? It is CH4, that is 4 atoms of hydrogen, that is 4 grams. Hydrogen is 1 gram only. Therefore, in hydrogen sulfide, for example, 32 grams of sulfur reacts with 2 grams of hydrogen. That is 64 grams of sulfur for 4 grams of hydrogen. Sulfur and carbon form compound, in which case C is to S, that is carbon is to sulfur, ratio is 12:60, that is CS2. The law is sometimes called law of reciprocal proportions, or it is also called as law of equivalent proportions. My dear friends, slowly you can do the problems by taking referring the textbook, so that you can learn all the 3 types. Thank you for listening. This is VVSM Academy. If you like our videos, don't forget to press bell icon and subscribe. Take care of the second COVID situation. Use mask and try to keep the social distance. Keep your health safe so that you can able to write the examination with successful and confidently.